So this is number 9. In both cases, we find that the magnitude of the velocity stays the same because they're traveling at a constant speed in a circle. So if we look at our changes in velocity for either case, the diagrams going to be the diagrams are going to be identical. So to find our change in velocity, we have Vf minus Vi. So Vf plus a negative Vi, since we're looking at vector addition here. I draw Vf, find Vf looks like this. A negative Vi would be pointing in the opposite direction. So at the end of Vf, I add a negative Vi. And then my change in velocity, which I will make green in this video, points down to the center. Now, in this, in number 10, they're asking you guys to explain what happens to your acceleration. And remember, our acceleration is delta V over delta T. So if we look at the first scenario, we have delta V over delta T. Our change in velocity points down to the center. If we look at the second scenario, we have the same delta V. All right, now let's deal with delta T. So the difference between the first circle and the second circle is if we have radius r, and we make this 2r, so essentially we're doubling the radius, the change in velocity is going to be the exact same. There's going to be no difference between this diagram here and the change in velocity over here because the speed does not change. So the change in direction of the velocity as it travels around the circle will still be down in the same amount. So these two delta V's are going to be the same. However, the time it takes, all right, this twice the radius, you're doubling the size of the circle, so it's going to take twice the amount of time. So if we do this, this would be 2 times delta T. So when we compare it to the original value, we get 1/2 of the acceleration compared to the original delta V over delta T. Now, this is not on here, but imagine you made this 3 times the original value of the radius. So if this was 3r, it's going to take you 3 times to travel that same arc length because your speed is not changing. So delta V over 3 times delta T will be 1/3 the original delta V over delta T. Now, if we look at this, as the radius increases, we find that the acceleration is decreasing. So we can state that the radius is inversely proportional to the acceleration. Now, if we take the idea from the prior video that the velocity or the speed squared is proportional to the acceleration, we can combine these two. Okay? In combining them, we find that the acceleration for an object traveling in a circle is going to equal v squared over r, where this is the speed squared divided by the radius of the circle. And remember, this acceleration, which is called centripetal, the word centripetal means center seeking. Okay, this can be substituted in for A in Newton's second law. This just is caused by the changes in the direction of the velocity, not the magnitude. Okay, so two things that are really important. We'll drive home tomorrow too. But this centripetal acceleration, again, is caused by the changes in the direction of the velocity as an object travels around a circle at a constant speed.